All right, good morning, everybody. How's everyone doing today?
Doing all right. How are you doing?
Doing all right, too. Thank you. All right. Several things to go through today. First thing, let's talk about one-day programs. So I've posted your first one-day program on Canvas, and let's take a look at that. So let me tell you a little about ODPs up front. ODPs are designed to be hopefully short assignments with 24-hour turnaround. I post it, typically 8 o'clock in the morning. I got it at like 9 this morning. But typically, I post it at 8 o'clock in the morning, and it's due 8 o'clock the following morning. Okay? This is your first ODP, so I'm actually giving you 2 days to do it. It's not due until Saturday morning at 8. But normally it'll be 24 hours. So it's a one-day program, that's the ODP. And the goal of these is to let you sort of self-assess your understanding of whatever it is that we're doing right now in the course. So for example, we might be working on a programming assignment, and this programming assignment involves manipulating a linked list. And we spend the class talking about how to add a node to the beginning of a linked list. Okay? And then the next morning you'll see an ODP pop up which asks you to write a piece of code which adds a node to the beginning of a linked list. And more often than not, I'll have actually given you the code for doing this, right? But not in the exact form that you need for the assignment. So you get the ODP, you try to write the code to do what it's asking for, and it lets you know if you understand the material that we've been going through. And if you understand it, chances are writing the ODP will take, a few minutes. If you don't understand it, it can take a lot longer. So today's ODP, you're going to have to write a hello world. It's a program that just prints out hello world. That's all it does. It's written in C. You've done this in CSE224B. I'm going to give you the code right now, and we're going to actually go through assessing it ourselves. And if you know how to write a C program, how to use the editor, how to compile it, no problem. This will take you 5 minutes. But, if it's been a year since you've done CSE224B, and you don't remember how to edit a file, and you don't remember how to compile it, and the first time you try, you end up corrupting your file and you have to start over, this could take you a longer time, okay? But the goal is that when you're done with this, now you've gone through, recently the steps of editing a file, compiling it, executing it, debugging it, all of that stuff. And it brings you up to a nice, level from which you can build for whatever we do next. So these, at some points they'll come to you every day, right? There may be periods where, there might be a week where we have 5 ODPs, one a day. And that can feel like a lot, especially if the earlier ODPs take you a few hours to do, but it will get faster, okay? And you'll get more comfortable with these. And once you're solidly up to speed in the things that we've been building on, right, the course will get easier from that point on. I've had 1 or 2 people in the past complain about ODPs. I've had dozens of people in the past tell me that this was the most valuable part of the whole course, right? More valuable than the programming assignments, more valuable than my lectures. This was where they learned the stuff, was through the one-day programs. So you really want to work on these. Don't go to Chegg for the answers. These ODPs are posted on Chegg, right? I told my violin teacher, I could pay someone to take my violin lessons for me, and she would be really impressed that I'd gotten so good, but that's not going to teach me how to play violin better. The ODPs are a learning tool, right? So getting the answers from someone makes no sense. I don't understand the mindset there. So work on these. You can talk to people about them, right? You can chat about them in Discord. You can absolutely ask me about them. But you got to go through the struggle, okay? So let's go through the first one together. So ODP 401, first one-day program, which you have 2 days to complete. It's due 8 a.m. Saturday morning. Write a C program named ODP 401.C. And that's going to print a single line which says hello world. Uppercase H, uppercase W. Followed by a new line, \n. Compile your program by saying, here's the compile command you want to use. And then assess your program by saying assess ODP 401. That's the name of the program you would execute normally. And then ODP 401.C, that's the name of the source program, the program that contains your C code. And then once you say assess, you get a little menu of options. Basically, you want to use the G command to grade your program, and then the X command to exit. There's a README on the Linux server under /temp/readme401 that has more information about this, including how to actually use the assess utility. Okay. There's also a video that you can click through to, 5-minute video that tells you how to use the assessment system. Okay, there's also an entry on Canvas that links to this, and it's on the CSE playlist on YouTube. All right, so let's go through the experience of doing this and make sure there's no surprises. So I'm going to go in as Goblin King. All right, and first thing I'm going to do, I'm going to look at that README under /temp. So it was /temp/readme401. So I'm going to cat that file. Okay, /temp is a general temporary storage area. If the system reboots, everything in /temp disappears. And it might disappear before then. But for short-term use, it's not a bad place to store a file if you don't want to put it in your own directory. So that's where the READMEs for the ODPs will pop up. So we can cat this, and it's pretty much the same thing that we just saw in the Canvas assignment. Now, going forward, the Canvas entry will not list all of the details. It will say ODP 402 C/temp/readme402. So you want to come to the server and read this. Okay. Echo hello world to standard out. Write a program in C which outputs one line of text, hello world. That's all the program should do. Print hello world followed by a new line. Compile your program into an executable called ODP 401. Assess it by typing this. And inside the assessment system, just use the command G. That will say, I want to assess my code, and it will give you a score. Okay? Typically 10 out of 10, 50 out of 50, 40 out of 50, something like that. For this, there's one piece to the assessment, so it's 10 points, and you get either 10 out of 10 or 0 out of 10. If you get 10 out of 10, you're done. Hit an X to exit the system. If you don't get 10 out of 10, recheck what the program's supposed to do. Okay, 2 notes here. So yeah, this is exactly an autograder that checks the output. So 2 things to note here. One, if you make any variation from what this specification is, you'll probably get a 0 out of 10. So the other purpose of ODPs is to get more practice in following a design spec. Because this is going to be really important here. It's going to be extremely important at a university. Because a lot of universities use these auto-grading systems for major projects. And if your program's supposed to, you know, do some amazing thing, and your program does that amazing thing, but in some slightly different way, or has an extra feature, or is named something slightly different, the grader might give it a 0. Right? So university, you might be in a class with, 80, 100, 250 students, and if your program doesn't work exactly the way that the teacher expects it to, they might just write 0 and move on to the next thing that they're grading. So we want to get some practice at following specs, and this is one way to do that. Okay, second thing to note, the program always records the last assessment that you made. So if I run this assessment 50 times, and the last time I get 10 out of 10, that's what goes into Canvas. Okay, 100%. If after I get 10 out of 10, I'm like, I wonder why this other thing didn't work, so I break my program and run it and get 0 out of 10, it's like, oh, I see, and I walk away. The last thing I did was a 0 out of 10. That's what'll go into Canvas. All right, and these early programs are just looking at the output of the program. As we move forward, we'll start writing functions, and the assessment will be based on how your function performs. And then it's a little less picky about, we're not going to be doing outputs, so there's no question of like having an extra space in between hello and world or things like that. But these early ones are very picky because all we're doing is looking at output. So let's write this. So I'm going to make a directory called ODPs. And I'm going to do all my work in this ODPs directory so that I don't see all this other stuff that I might be doing in the course. So I'm going to make my file odp401.c. So we're going to put in standardIO.h. That's always our first line. We're going to make a main program. Alright, and I'm going to compile it. And then I'm going to assess it. Right, and I'm just following these instructions verbatim. Right, I wrote my program, this is how I compiled it, this is how I'm assessing it. Alright, when you get into the assessment system, you'll see, a welcome message. It'll tell you your user ID. It gives you a list of 3 commands. Submit your code for grading, exit the system, or help. And help just gives you these 3 lines of text. It's not particularly helpful. Note you may submit your assignment for grading more than once. The latest submission will be counted. Okay, now before you do anything else, take a look at what's down here in between these rows of asterisks. It says you are about to assess your code for ODP 401. Write a C program that outputs exactly hello world. Make sure that's what you think you're supposed to be assessing. Okay, if I'm trying to assess ODP 402 and I put in my assessment and it says you're about to assess your code for ODP 401, stop what you're doing. If I submit the wrong program for grading right now and I get 0, I'm going to end up with a 0 for ODP 401. And maybe I already got 10 out of 10 and I'm just working ahead and I'm trying to do the next ODP, but it's not time to do that ODP yet. So make sure if you're doing ODP 401, this says you're about to assess for ODP 401. Okay, that is what we're working on here, so I'm going to go ahead and submit this for assessment, uppercase G, and I get 10 out of 10. Alright, I'm done, I'm good to go, I can just exit. Alright, so what can go wrong? I forgot my backslash in. It didn't notice I didn't have a backslash in. I write my program like this, right? I assess it, I say submit for grading, I get 0 out of 10. Okay, so what do I do at this point? Exit the assessment system, run your program yourself, right? We compiled ODP 401 into an executable program called ODP 401. Sorry, we compiled the .c into an executable called ODP 401. Okay, that's what this line does. Remember, call the C compiler, make the output file ODP 401. Here's the source file I want to compile. So my executable program is called ODP 401. You should be able to just run that. Just type in the name ODP 401 and it says hello world. Alright, so you can ask, well, what's wrong with that? Why didn't I get 10 out of 10? Go back to your assignment. Okay. Look at the assignment in Canvas or look at the README under /temp. And here it says, prints a single line that says, hello world, pay attention to uppercase, lowercase. So at some point, hopefully you stare at this, you realize, oh, the H and the W should be uppercased. Okay? That can be really hard to find. And it's one of these things where, maybe you need to step away, take a walk, put on some music, clear your mind, come back to this with fresh eyes, okay? And stare at this and say, oh, that should be, uppercase H, uppercase W. Programming is probably the most intolerant subject as far as something needing to be exactly a certain way, right? Physics, if you're supposed to start a cylinder 1.5 meters up an inclined plane and measure how long it takes to roll down, if you start at 1.6 meters, you're going to get about the same answer. If you don't hit your stopwatch button exactly at the moment when it reaches the bottom, you're probably going to get about the same answer, right? Most subjects, there's a fair amount of room for, there's tolerance for error. Computer programming, not so much, right? A single character change in the middle of a huge program can totally change the way the program behaves. And you can go on YouTube, you can find videos of like computer program error related disasters with lots of explosions and things like that. It's a very unforgiving subject in that way. So it can be hard to look at this and say, I'm printing out hello world, why am I not getting my 10 points? Okay, so that's the other part of what we're trying to develop with ODPs is our ability to do those kinds of analysis. All right, so I fixed my ODP program. I change it to be uppercase. I recompile. I reassess. I grade. 10 out of 10. I'm done. Hit an exit. Go on with your life. Questions about that? And this is the only code you need for that program, and I don't mind if you just take this verbatim and type it in, right? The code itself is not the real point of the ODP. It's getting into the editor, making the file, compiling it, assessing it. All right, let's talk a little bit about getting help if you're stuck. So let's go back to where this wasn't working. All right, so you do this and you look at your code and you look at the output and you say, oh, I'm supposed to be doing uppercase. Okay, so you go in and you make that change. You recompile ODP 401.c, you assess, you grade, you're still getting 0 out of 10. All right, so at this point you're really frustrated. You were pretty sure that that you fixed the problem. You went away, you took a walk, you came back, you found the lowercase h and w, you changed that, right? And you assess, and you're still getting 0 out of 10. So this is a good time to send me an email, right? And say, hey, I don't get it. I don't see why I'm not getting points. So how do you do this effectively, right? If you just send me an email and say, my program is perfect, but I'm getting 0 out of 10, what's wrong? I can't tell you. Okay? I'm not clairvoyant. I'm not sitting in front of your computer watching what you're doing. I have no idea what's wrong. You got to give me some information. All right? So here's some information that would be useful for me to know. Start off, show me the date. Just for kicks. Show me your directory. Okay? Show me what's in your directory. Show me your program. Show me how you're compiling your program. Show me how you're assessing your program. Show me the result of that assessment. And now take all of this, put it on your clipboard, go into your mail program. I'm not going to bring up my mail program, but I'll just bring up a WordPad. Go into your mail program, paste all of that in as a plain text email message, send it to me, nmaciasclark.edu. And now I can look at this and I can tell what you're doing. And in this case, for example, having your source code, seeing that this is what your program looks like, does not tell me what the problem is. Because you're right, this program is perfectly correct. This should get you 10 out of 10. But it's when you compile it that you're making an error. Because you compiled it, you didn't tell it to call the output file ODP401. You just said GCC ODP401.c. You compiled into an executable called a.out. And so now when you assess ODP401, you're assessing an old program, not the program you got by compiling this. Okay? I can't tell that by looking at your source code. I can't tell that by looking at the logs inside the assessment system and seeing what your code was that you submitted. We only know that by looking at the process that you went through, you know. Or maybe you assess it, but you're actually assessing ODP 400 instead of ODP 401. There can be a lot of things that are causing you to get 0 out of 10. The more information you can give me in an email, the more chance that I can point you in the right direction. Someone asked, couldn't you also use a bunch of printfs? I'm not sure that would do the same thing as you know, letting me see how you compiled your program, how you're assessing it, and so on and so forth. So don't send me screenshots, right? Screenshots don't work. They're good in a pinch, right? But you know, open a fresh terminal session, go through all the steps you're doing, just copy it, set up your terminal program so you can copy the text somehow. For me, just highlighting text puts it on the clipboard, right? Paste it into an email message. And that at least gives us something to talk around, right, as far as trying to figure out what's going on. All right, so do the ODP like right after class if you haven't already done it right now while I was talking. Do not wait until tomorrow afternoon to try the ODP because I'm not available for help after class tomorrow, right? So try it today. If it's not working, you can send me an email. We can talk about it. Worst case, we can talk in class tomorrow. Okay, but by tomorrow class time, you either want to have finished this assignment or you want to know exactly that you're having a problem and what you need to figure out in order to get it resolved, and then we can talk about it in class. All right, does that make sense? All right, let's talk about customizing your environment. So let's say I'm doing a lot of ODPs, right? And every time I want to start an ODP, I have to say current directory ODPs. And I have a hard time typing uppercase ODP with a lowercase s. Here's something I could do. I could say alias, I don't know, O equals CD ODPs. All right. So now when I log in, I'm sitting here at my home directory, right? If I want to change my directory, I just type the letter O, and guess what? I'm in my ODP directory. Okay, that's kind of a silly example. But I can set up shortcuts, aliases, where I have a symbol that represents something else. If I just type the word alias, I can see all of my symbols that are set up. So QA changes me into this directory, backups does a backup command, GCC is a shortcut for this modified version of GCC, and so on and so forth. Alright, so my O command changes me into my ODPs directory. But the next time I log in, if I type the O command, it doesn't know what I'm talking about. Because aliases and symbols and all these things that we set up, they're temporary. They go away after you log out. So if you have things that you want to make permanent, you can put them in a file in your home directory called .bashrc. So look in your home directory, there's no .bashrc file in there. But there's actually more files than ls is showing me. ls is written so that it only shows you files that begin with a letter or a number or some character other than a period. And if I make a file that begins with a period, and I say ls, I will not see that file. There's nothing special about a file that begins with a period, but ls is written so that by default it doesn't show you such files. If you want it to show you those files, you can say ls-a. And now I see the files I saw before, ODPs, save, and work, but I see these other files that start with a period. Okay, including my .haha file. So what are these for? Well, they contain different types of information that's useful to have in files in your home directory, but you don't necessarily want to see every time that you say ls. So for example, bash history, that's where the history of all of my commands is stored. .bashrc is a file that has commands that are executed every time that you log in. So let's take a look at our bashrc. So my bashrc does things like, for example, it sets this variable ps1 equal to an exclamation mark inside curly brackets. Well, that means show me my command number inside curly brackets. But if I change this, if I said ps1 equals 3 greater than signs followed by a space, the next time I log in, my prompt has changed to 3 greater than signs followed by a space. I can add something at the bottom here which says echo. Echo is a command we use to print something out to the display. I can say echo hello Nick. And now the next time I log in, it says hello Nick. So you can put whatever you want in here, right? But typically we use this if we have things that we want executed every time that we start a new bash session, and we don't want to type those in, we can put them inside our bashrc. And common things you'll do will be, for example, setting up aliases, right? Having one command that means something else. So some people like to use the command LA as an abbreviation for ls-a. So I can say alias LA equals ls-a. And now if I say LA, it shows me all my files. Right, I can set up home to be an alias for change my directory to my login directory. And now if I go into some subdirectories and I just say home, that brings me back home. So as you continue to work with Linux and you start finding things that you do frequently, you might want to make shortcuts for them and throw them into bashrc to have them take place every time that you log in. And bashrc, you know, theoretically the whole thing gets executed. Your bashrc will look different from mine. And there's all kinds of structure to this. So somebody just asked in chat, is there an advantage of putting an alias in here instead of bash_aliases? So I don't know how I have it set up for students, but usually there's another file called bash_aliases. You can just put your aliases in there, and .bashrc will execute the stuff in bash_aliases. It's all about organization and being able to manage this stuff. If you're doing this on a large scale system where there's, you know, a group of users you're trying to support, then you do things one way. You're doing this strictly for yourself, right? And you can pretty much do anything you want. You can blow away the entire bashrc script and start from scratch, right? Or just do the things that you want, and then in the top, just have it exit. So it's totally up to you. There's aliases. There's ignore EOF. So right now, if I hit Control D, it logs me out. If I said ignore EOF equal to 5, and I log back in again, if I hit a Control D, it says use logout to leave the shell. I can do that 4 times, and it'll keep telling me use logout. If I do it a 5th time, it'll actually log me out. You have to do it 5 times pretty quickly in a row. And then I logged out of my home system too. And there's tons of things you can do to customize your environment. And sometimes, you know, you get bored or your brain needs a break, you go off and you start doing some reading and you look at ways you can customize and you play around with some changes. It's something to do, right? Set my history to 5,000 so I can remember 5,000 commands that I've typed in. And somebody just pointed out color identification. So normally your session will be color coded. Like when you do an ls, you'll get different colors for directories, executable files, source files, and so on. And there's also color coding available inside VI. So syntax highlighting and so on. I have that stuff turned off just because I'm old school. But I think it's turned on by default for most students. So that's an option. All right, let's talk about some Linux commands. So, we know some basic commands already, right? So we know ls for listing files. We know ls-l for seeing a long list of files. ls-a now for hidden files. ls-al for doing both hidden files and a long listing, which by the way is the same thing as ls-la because the order of these switches doesn't matter. We know the date command for seeing what the current date is. Here's a command called uptime. This tells me how long the system has been up since the last reboot. Okay, this one's only been up 19 days because I rebooted it before the term started, after I pushed over the old files to an archive and so on. But you know, typical Unix system, this will be, you know, hundreds or thousands of days that the system has been up. Unix doesn't really get rebooted unless there's some, you know, major security reason why you need to, you know, load something new in the kernel. But other than that, you know, systems will run for years without a reboot. So uptime shows me the current time, how long the system's been up, how many people are logged into the system, and then load average. This is a measure of how busy the CPU is basically, and it's current load average, I think 1 minute average and 5 minute average. And numbers around 0, numbers less than 1 means the system's really not doing a whole lot. If this number gets up to around 3 or 4, the system is definitely busy. If it gets up to 7 or 8, you're probably seeing a slowdown and something significant is taking place. So that just gives you an idea what's going on in the system. Word count is a fun little command. Word count lets you type in a bunch of stuff, and when you're done typing, in this case I'm going to hit a Control D to say end of input, it prints out 3 numbers. So this first number 4, that's how many lines of text it saw. 12 is how many words it saw, where words are things separated by spaces. So this is a test, testing 1, 2, 3, hello, bye for now, that's 12 words. And then 47 is the number of characters. Alright, Unix has, thousands of commands. Some of those commands have dozens of switches. There's a lot that we could spend our lives learning about Linux, but we're not going to do that. We don't want to try to fill our heads with, all these different commands that are available, all these different things we might type and what they do. What we want to do is just learn a small subset of commands that are useful for us. Someone asked with word count, does the new line count in the character count? I believe it does. So let's make a test file. And so test has 6 characters in it. HELLO followed by a new line. If I do word count test, it's got 1 character, 1 line, 1 word, and 6 characters. And if I XXD it, I can see exactly what those characters are. Hex 48, 65, 6C, 6C, 6F, and 0A. So yeah, word count will count new lines. Alright, so we're going to learn a small set of commands. Word count, ls, grep, things like that. Control D gets you out of word count. Control D gets you out of most commands. It's the end of file marker. Alright, we're going to learn a small set of commands. We're going to put them together. Okay, for example, suppose I want to know how many files are in my directory. Well, I know if I say ls-l, I get, 1 line of output per file plus an extra line up here at the top. So if I were to take all of this and put it into word count will tell me I saw 5 lines of input. Well, if I take 5 and subtract 1, I got 4 files. Alright, so what did I do? I executed a command, I grabbed the output using my mouse, I ran another command, I pasted what I had copied for the input. There's a way to do that automatically in Unix, and it's called a pipe. And a pipe is represented with a vertical bar, and the vertical bar basically says take the output of one command, send it to the input of another command. So if I say ls-l and I pipe that into word count, there's my 5, 38, and 233. If I just do ls, I don't get that extra line in the top, and it tells me correctly I've got 4 files. And you may notice if you just do ls, it looks like I've only got 1 line of output, but the system, the code in ls knows if the output is going somewhere other than my display, it should display 1 file per line. So this is actually what the output of ls looks like. And so if I put that into word count, everything works great. If I do an ls-a pipe into word count, I can see I have a total of 17 files, including hidden files. Alright, another powerhouse command is grep. Grep is a search command. So we can say grep pattern, and that will search its input for any line that contains whatever this pattern is. And I can put a file name after here that it will search. If I don't put a file name, it will just read from its input and look for things that contain that pattern. So for example, if I want to know if Goblin King is logged in, I could say who, and I could pipe it into grep goblin, and I see one line from who that had Goblin King in it. If I want to see if Nick's logged in, I can do a who, pipe it into grep Nick. I can see Nick's logged in twice. So we can start putting commands together. And that turns out to be really useful. Another useful command is called watch. Watch lets us type a command, and it will run that command periodically and show us the output. So if I say watch date, it executes the date command every 2 seconds, and I see that date changing here. So I have a nice little running clock. And someone asked, can you do multiple pipes in one line? Absolutely, and you usually do. And that's where this gets really powerful, taking the output of one command and sending it to another and sending it to another and so on and so forth. So there's a command called ifconfig. Shows you information about your network interfaces. And in particular, it tells me that my network connection is up. And it tells me how many bytes I've received and sent, and how many packets have been received and sent. And if I put a watch in front of that, it'll show me this information updated every 2 seconds. So I can monitor my network traffic here. And so all kinds of possibilities. Alright, there's a fortune teller program called Fortune. Type Fortune and it will give you a little fortune cookie message. And it's random, and I didn't write this, so I'm not responsible if it says anything inappropriate. I'm not going to read all of that. There's also a version that a student wrote a few years ago called Ask Khan, which shows you fortunes that he thought were appropriate for the CS sequence of classes. So he wrote some computer-related fortunes. So that can be a nice break from coding. There's also a command cowsay. If you say cowsay and you type something in after it, you get a picture of a cow telling you whatever you typed. So I can take the date and I can pipe that into cowsay. Now I have a cow telling me what the current date and time is. If I put that at the bottom of my .bashrc file every time I log in, I'll get a little talking cow. If I take fortune and I pipe it into cowsay, I get a cow that tells me a fortune. Alright, another thing we can do is we can redirect output from a file, from a command, into a file. So I can say something like command greater than, and put in the name of a file, and the command will execute, but instead of seeing the output on my display, I'll see the output going into a file. So for example, if I say date, and I put that into a file called XX, I don't see any output from the date command, but I have a file called XX now that has whatever date produced, which was the date and time when I ran that date command. Right? And it doesn't change, it's a static file. I can take date and I can put that into cowsay, and I can put that into something called file2, And now if I look at file 2, it's got the output of date piped into cowsay. We can also redirect standard in with a less than sign. And this will run a command, but it will read its input from a file. So if I say something like ls and I put the output into A, so A is a list of all the files in my directory. Now I can say word count and I can read the input to word count from the file A. And I've just done a pipe without using a pipe symbol. Right? I ran one command ls, I took the output, I sent that to the input of another command, word count. It's exactly the same thing as just doing ls pipe into word count. So these are building blocks, okay? They're things to play around with. They're things that you should start messing with and try to get familiar with, get comfortable with, and let your mind start going to them. When you're trying to solve some problem, this is one way to think about solutions, is by taking pieces, building blocks, tools, and putting them together in different ways. Alright, so tomorrow I want to start talking about doing some actual programming in bash. So we'll start making shell scripts and we'll start executing commands in there, and then we'll see how to start doing things like conditionals and loopings and working with variables and so on and so forth. And this will lead us into our first large programming assignment, which I think I'm going to discuss on Monday. So start shell scripting tomorrow. Work on the ODPs today. Let me know if you're stuck. And I will see you in class tomorrow. All right, thanks.